Hello everyone, my name is Winston. Today I'm going to show you how to implement Minimax onto Ultimate Tic Tac Toe. Before talking about Minimax, I would like to explain how the rules of Ultimate Tic Tac Toe work first, because I find that many people actually have never heard of this game before. How this game works, as we can see, there's one global board, and in the global board there are 9 small local boards, and where a player makes his move will determine which local board the opponent is able to play on. So at the start of the game, the 9 local boards are available. It means the first player is allowed to choose any local board he wants to make his first move. For example, if the first player make a move here, then his opponent will be only allowed to make his move here. Because player X has made his move here, opponent is only allowed to play on this local board. And because the opponent play here, this square, so player X is also only allowed to play in this local board. However, when the next board the next player is about to play has been either fully occupied or have been won by either player, then that player would be allowed to choose any local board he wants to play on. Let me explain it. If I make my move here, since this local board has already been won by one of the players already, the opponent will not be able to make his move here. So he will be allowed to choose any of the still available board to play on. So if I make a move here, he can choose any of these 8 local boards to make his move. And opponent chose this local board to play on. How to determine who will be the winner? So if one of the players get 3 local boards in a row, then he will be the winner. Or if at the end no one can get 3 local boards in a row, then it will be a draw game. And so you can see player O has won the game. And now let's have a look at the code. So for the global board, I use an array to represent the global board, and for local board, I use an array of arrays to represent. So from 0 to 8, it represents the 9 local board, and in the local board array, each array of the array represents the square. So total, there are 81 squares. And for the Minimax function, so for the first 2 variables represent where the player will make their move. So for the global here, it represents one of the 9 local board, and in one of the 9 local board, he will need to choose one of the 9 squares. And here, the alpha beta tuning, so I have explained what it is in my last video, so I will not cover it here. For the math steps, because Ultimate Tic Tac Toe is a little bit more complicated than a simple Tic Tac Toe, so we should not let the AI to explore the whole game tree, because otherwise it will use up all the computational resources and the browser will get frozen. So we should only allow the AI to explore the game tree up to a certain depth. So because I understand that usually a mobile phone will have less processing power, so I only allow maximum depth as 4. But if this is on a PC then or laptop, then the maximum depth would be 6. And what this means? So if this is 0, it means the AI will only think about what the best move for his current turn. But if this is 1, it means he will also consider for the next turn where his opponent will make his move. And for 2, it means after he consider next turn where his opponent will move, he will also consider which move he should make after his opponent has made his move. So here 4 means the AI will think 4 steps ahead, and 6 means he will think 6 steps ahead. In order to determine where the move should be made, we need to have a score. Please notice that this score is not for the move itself. It is also not for only one player, but this is a score for the whole board. So it is shared by both players. And at the start of the game, the score will be 0. And remember, Minimax, one will be a maximizing player who wants to get the score as high as possible. And another one is minimizing player who want to get the score as low as possible. So at the start of the game, the score will be 0, which means that both players have an equal chance to win the game. So as the game goes on, for example, if the score now becomes a positive number, it means that the maximizing player will have a higher chance to win the game. So how we determine the score? We have the erase board function. So after each move, we will have the minimax to calculate the score. And remember that from a simple tic-tac-toe, the center square is the most important square, and then the next, the second most important squares would be those in the corners, and for those on the edge, it will be less important. So we will have a higher score for the center one, as shown here. The center will have a higher position score, and then the next highest, the second highest would be for the corner. And it also applies to the local board. So the center local board would be the most important. So it has the greatest rating. And for the corner one, they are still important. So they have the second greatest rating. So as shown here, the center local board will have a greater rating than other local board. And also we have scores for different situations. For example, in a row, if there are 3 O's, it means the player O will win the local board, correct? So it will have a negative 12. And if in the 3 squares there are 2 O's and 1 empty square, then it will be negative 6. So it is still favoring the minimizing player. And if there is 2 X and 1 O, it is still favoring the minimizing players, which means that it will encourage the minimizing player to put an O in a row where there are 2 X and 1 empty squares. And it also discourages the maximizing player to put an X in a row where there's 1 X, 1 O, and 1 empty square. And if one of the local boards has been won by a player, the score for the board will be added or deducted by the position scores multiplied by 150. For example, if a maximizing player has won the center local board, the score for the board will be deducted by 0.4 multiplied by 150. Since the score is so significant, it will encourage the player to win the local board. And at the end, if a winner is determined, so if a player can make 3 local boards in a row, then the score will be added or deducted by 50,000. So if it is a maximizing player, it will add 50,000 on top of the current score for the board, which means that it will encourage the player to win the game because the score is so high, 50,000. Thank you for watching this video. I hope you now understand how Minimax works in Ultimate Tic Tac Toe. And in order to make it work, we need to have the alpha beta pruning, which have been covered in my last video. We also need to have max depth because we don't want to exhaust all the computational resources. And we need to have a evaluation board, so it will evaluate the board after each move. And remember, that score is not for the move itself, but for the whole board, and the score is shared by both players. I have also included my code in the description, and you can play the game too. And hopefully you can also beat the AI. Remember, the AI is still beatable because the Minimax function is not exploring the whole game tree. And for the PC or laptop, it can only think 6 steps ahead. So if you can think, for example, 7 steps ahead, you could actually outsmart the AI. So you can still have a chance to win the game. Thank you for watching. See you